Good evening to all. Hope my screen is visible to all of you.
Yes, sir.
Okay, fine. So actually one student asked me about the list operation to create function in the list operation 2 file. I'll explain it once, then we'll start with the today's session. Okay, so this is list of 2 file. Here we have create list function. Okay, so for this create list function, we are passing a double pointer structure list L1. Okay, from main we are calling this create list function. We are here we declared one pointer variable, and this pointer variable's address we are passing to the create list function. Okay, now this will go to this create list function. Here we are allocating the memory. We are creating memory for the create list, and suppose if there is no sufficient memory, this will return null. If it is null, return 0. It means error condition. Otherwise, memory is successfully created. So initialize the count value to 0 and initialize the head value to null. Okay, maybe you may have some doubt like why we are passing double pointer. Why means for this L1 variable here we are not passing address of a variable. Here what we are doing means we have created L1 as a pointer variable. So pointer variable means memory is not at all allocated. Okay, so whatever the L1 is pointing to, so this pointer variable's address we need to point send. Okay, this pointer variable that means L1 itself is a pointer variable and its address. Okay, so pointer to pointer. That's why here we are using double pointer. Okay, so in wherever the in this L1's pointer we are allocating the memory and checking whether it is equal to null. Okay, the same create list we have used in all our other programs. Okay, suppose if you are unable to understand this concept, okay, suppose you are finding it to understand the double pointer concept, one more thing you can do, you can use the return type. Okay, return type as a struct list, and the same function you can change it in other way. I'll do it now. Now I have created the list and I'm going to perform the operations. Then I'll explain. Just 1 minute. Okay, so here it must be L1 equal to create list of L1. And here L1 equal to null. Let us check it. Here now three values I have inserted 100, 200, 300. Then display data. See 300, 200, 100. Now it is inserted successfully. Now let us check it once. We'll discuss the code once. Okay. See here earlier for this create list function I have used a double pointer. So the people who are not comfortable with pointers may feel this as a little bit difficult. Why we are using double pointer? Okay, because we are not passing a normal variable. Suppose int a you create in main, and that you are passing to a function means then address of a you will send here one single pointer you will send. But this L1 itself is a pointer variable in main, so memory is not at all allocated there. Okay, so to create a memory in that pointer variable, we are using the double pointer. Suppose if you are unable to understand this concept, just instead of create list, you can use create list 2. See, in create list 2, I am using a normal single pointer. Okay, and for the pointer variable, I am allocating the memory. Then L1 equal to null, checking. If it is so, return null. Okay, return null. Otherwise, initialize the count value and head value. Okay, and see here, its return type is a structure pointer. So you are allocating the memory within the function. and that memory is a reference you are returning. Okay, so you have to store this whatever memory we created, it must be stored in a variable. So here, while calling in main, L1 equal to create list2 of L1. Okay, instead of this type of if statement, here we are using this type. Okay, and we are checking whether L1 equal to null. If L1 equal to null means list creation error. Okay, now we discussed about the output also. Okay, so wherever we are using the double pointer concept, suppose if you are unable to understand that concept, you can use a return type also. But what is the problem means a function can return only one variable. Okay, suppose if you are going to process more than one double pointers, which case the parameter you have to send it only in the parameter as a double pointer value. Okay, that's why we're using the double pointers. So in this case, since it's returning only one address, no issues, we can convert the create list into create list 2. Okay, both codes are valid. Okay, so any doubt in this? What is the purpose of counter? Arjun explained it, thank you. And yes, fine, Saget also explained. Okay, so any other doubts? Okay, so we'll move to the today's topic. So okay, so in the previous session we discussed the 5 operations in the linear linked list. Okay, what are the basic operations we discussed means we discussed create. Okay, creating a list we discussed, then inserting a node, insert beginning, insert the into the list, so that we discussed, then delete we discussed, and then searching operation. Okay, list search we discussed, and then we discussed about traversing a list. Traversing a list means displaying the list. So totally 5 operations we discussed in the previous class. Okay, so the rest of the five operations are not that much important. Okay, so, and it is very simple to implement also. Okay, that we will see, that is to checking whether a list is empty or not, to checking whether a list is full or not, and how many values are there in a list, and destroying a list. Okay, retrieving a node from a list. Okay, so these are all the remaining 5 functions. Okay, retrieving a node from a list, it is equal to the list search, because in list search what we are doing means we are searching for a particular value. If it exists, we are returning true, and also the address of the particular node is stored in the location. So it is equal to the list search and retrieve node. Okay, and what is the empty list? How you can say whether a list is empty or not? Any idea? Students, any idea?
Point null. Point will be null.
Count will be 0, sir.
Yeah, 2 ways are there. The first thing is
Count
we have
will
a
be
count variable. If a count is 0 means the list is empty. Otherwise, if the list head, if it is pointing to null, it is an empty list. 2 ways are there. So you can write algorithm using any one of these. Okay, both are valid. And the next is full list. Actually, to check whether a list is full or not. Okay, it is difficult. Why means we are using dynamic memory allocation concept. So in dynamic memory allocation, in runtime means during the execution time, we are allocating memory and creating nodes. So the operating system will allocate a certain amount of memory for each program. Okay, if you are writing a Windows XP or Windows 10 or Windows 7 operating system, okay, and you are running a C program, list of 2, list of 3, any C program, for that program, the operating system will allocate certain amount of memory. Okay, within that memory only, we can able to allocate memory for the nodes created. So if you're using malloc CLR, within that space, it will allocate memory. Okay, so while calling the malloc or CLR, if there is no sufficient memory, it will return null. Okay, but there is no full-featured functionality to check how much amount of memory remain available. Suppose 1 MB is allocated for list operation 2 function program. Okay, and we utilized 500 MB. The remaining is 500 MB. Okay, it is difficult to check whether the remaining how much memory is remaining. Okay, so simply we can write how much memory available. We can write the algorithm, but it is difficult to implement it. Okay, the next is a list count. So how you can get number of nodes in your list?
While traversing, we can increase the count, sir.
Yeah, very good. Actually, suppose in exams they are asking you to implement this means please use that method. Okay, display method we already discussed. The display method you try to convert it. Initialize a count variable, and within the while loop increment the count by 1. Okay, and return it. Okay, so that is the correct way of implementation in exams. But if you means in exam itself, suppose if they are asking all the operations, creating list, insert, delete list, all the operations are asked in one big question means, okay, in such case you can use the count variable. Okay, because we have a count variable in the list itself. The count variable value we can return it. Okay, suppose if they are asking you to write algorithm only for the count operation, okay, then don't write simply return list one count. Okay, because what is the structure of the list, the evaluator don't know. Okay, and it is not their intention. Okay, count is stored in some structure and directly we can return. Okay, because insert function not implemented. Okay, delete function not implemented. In insert function only we are incrementing the count variable, and the delete function we are decrementing the count variable. Okay, so that functionalities are, you are not going to write it in the exam. Suppose if they are asking only the get count function. Okay, so in exams if they are asking to write algorithm for getting count the number of elements in the list, in such case you have to use the while loop and count variable incrementation, and finally you have to return the count. Okay, don't simply return list count value. Okay, and finally destroying a list. This is very important. Why means in any C program, when you are declaring int a, what is happening here?
Memory is created in stack.
Correct. Memory is created. Okay. Suppose integer size is 4 bytes. 4 bytes of memory is allocated for A. Okay. When you say float to B, some amount of memory is allocated for B. Okay. This memory is allocated by the C compiler. So we need not worry about deallocating the memory. Okay, whether whatever the 4 bytes of memory allocated for A, whether it is retrieved or not, such kind of worries we need not worry about it. Okay, but whenever we are going for malloc cloc, this malloc cloc functions are user defined memory allocation functions. So we are instructing the compiler to allocate certain amount of memory into a variable. So the compiler will not deallocate this memory. Okay, whenever you are performing the delete operation, okay, whenever you are not using any list, you have to remove all the memories. Whatever the memory is allocated, that must be freed. Okay, so destroying a list in delete operation, we will use the free function. Okay, even if you're not giving the free function, some programs will work. It doesn't mean that the program is correct. So once the node is not used, we need to call the free function to delete the node. Okay, so destroying a list.
Yes, sir.
Yes.
Sir, what is the difference between using delete and free, sir?
Very good.
When should we use free and when should we use
delete? Wait. Anybody know answers for this? I'll explain later. Any other students?
Sir,
Delete means
Sir.
we will delete.
Yes.
Delete means we'll
Sir.
delete only the variable that is asked, sir.
Okay.
Free means whatever is created, it is freed, sir.
Okay. Actually, delete is a CPP functionality. Okay. When you use new, you will delete it. In CPP, okay. In C, we have malloc cloc free only. Okay. Let us check it. Suppose here. Memory allocation in C, if you are searching, okay, whatever the functions you will get means the malloc, cloc, and free. Okay, let us do memory allocation in C++. Okay, we will get new and delete operators. Okay, so malloc, cloc, free are called as a functions, and new and delete are operators which is used in CPP. That is the difference, nothing better. Because you are studying both the languages C and CPP, sometimes you may get confused between the functions in C and CPP. So free is a C function and CPP, sorry, delete is a CPP operator. Okay, got it? Any other doubt?
Thank you, sir. No other doubts, sir.
Okay, fine. Okay, now let us move the detailed discussion. Okay, so here the create list we discussed, then insert beginning, display list search we discussed. Okay, list count. So this is the algorithm. As I already told you, so in this algorithm, I am simply returning list count. Okay, so this is one way. Okay, the implementation I have, this is the second way. See here, list count 2, the second algorithm. Here, set count equal to 0 and set walker equal to list head, loop walker not equal to null, increment count by 1. Okay, and here I have to add one more statement, walker equal to walker next. Okay, so 2 set if you're not giving this statement, the loop will not execute. Okay, the walker will not move to the next location. So walker equal to walker next. So this statement is important. Okay, and at the end return count. So this is second version of implementation. In the first version, we are directly returning list count because in our head node we have a count variable. So whenever we are inserting a value, we are incrementing the count variable, and whenever we are deleting a node, we are deleting the means we are decrementing the count variable. Okay, so this is one algorithm, and the second algorithm is setting a count variable and incrementing it within a loop. Okay, we are going to each and every node and incrementing the count variable. So this is the correct implementation. Okay, now checking whether a list is empty or not. Okay, here list count equal to 0 means return true, otherwise return false. This is one way, and the other way, as we discussed, if list head is null, okay, list head is pointing to null, then the list is a empty list. Okay, and the full list, as we discussed already, it is difficult to say whether memory is full or not. We can simply write memory full, return true, list is full, otherwise return false. But there is no concrete implementation available in C. Okay, in C it is not possible to check it how much of memory available remaining. Okay, and the implementation, C implementation for get count. Okay, so this get count code is more or less similar to the display function. Okay, so get count, we are passing the list variable, and one temporary variable we are creating, set node walker equal to list one head. So list one head is the first node in a list, in any list. So from first node till last node we need to move on. Okay, so walker not equal to null. Okay, iterating the loop until walker not equal to null, count plus plus, walker equal to walker next, return count. So this is count implementation. So the simplest implementation, suppose insert delete functionalities asked in the exam means you can write the second version of the count. Okay, so this one you can implement. Okay, simply returning the count variable. Okay, the next is destroying a list. So while destroying a list, what we need to do means we need to delete all the nodes first. Okay, before deleting the head node. So in this algorithm, we are not deleting the head node. Suppose if you are planning to delete the head node also, before deleting the head node, we need to delete all the data nodes. Without deleting data nodes, if you are deleting the head node means we will not have access to the first node. Okay, if we have access to the first node, then only it's possible to navigate to the next node. Okay, so whatever the memory allocated, the memory will be it will create a memory leakage error or dangling pointer errors. So memory related errors will rise. Okay, so while deleting the list, we must ensure that before deleting the head node, all the data nodes are deleted. Okay, here also the iteration we can use. Okay, until the end of the list, we need to delete each and every data node and finally set the count of the list to 0 and head to null. Okay, so that codes we will discuss now. See here, the list of 3 get count. Okay, so get count, first one temporary variable walker, then count, and then walker equal to L1 head, then until walker not equal to null, count plus plus, walker equal to walker next, returning the count. So this is get count functionality. Okay, and the empty full I have not implemented. You can implement and check it. That is sorry, not full, empty you can implement and check it. Okay, and this is destroying a list. So in destroying list, first until L1 head not equal to null, temp equal to L1 head, L1 head equal to temp next. Okay, L1 head equal to temp next, free temp, the first node you are deleting. Okay, and the second node's details you stored in second node, you are making it as the first node, and then first node you are deleting it and repeating it until you delete the last node. Okay, let us check the program. See here, insert operation, display insert operation. I'm inserting some values, 10, 20, 30, 40, 50. Okay, totally 5 elements I have inserted. Now display the list. Okay, 50, 40, 30 inserted. Now list count. List count is the fifth option. So number of elements is 5. Again, I'll insert one more element, 70. Now I'll check list count, 6 number of elements. Let us delete some element. Element to be deleted is 30. Deleted successfully. Now display. See, 30 deleted. And again, if you are checking list count, it is 5. Okay, the element deleted. Suppose if I am calling destroy list, it will delete all the elements in the list. Okay, let us do it. 6. Okay. Are you sure you want to delete the list? Yes means 1. Okay, yes, all the elements are deleted now. Now let us try to display it. See here, no list found. Okay, no list to display. Now 7, exit. That's it. Okay, so this program also I'll upload it in Google Classroom. Okay, now the list operations are completed. So list operations completed means I am again insisting you that please practice the insert operation, delete operation, search operation, and then display operation in the list. Okay, these are very, very important, because if you're understanding this concept, then only it's possible to insert the next concept. There is a stack. In stack, we will use the insert delete operation. Okay, and after that we will use queue. Queue also we will use the insert delete operation. Okay, so again in a linked list, we are going to once again create linked list for stack also and linked list for queue also. So if you are not understanding this linked list concept, general linear list implementation using linked list, if these operations, if you are not comfortable, means it is very difficult to understand the next two topics, that is a stack and queue. Okay, so please practice these programs. I'll share these programs with you. Please practice these programs, and if you have any doubt, get it clarified as soon as possible. Okay, so now let us move to the next topic, that is stack implementation. Okay, so the next data structure that we are going to discuss is the stack. Okay, so what is a stack means? It is one type of data structure. Okay, so here we will store the data and we will perform the retrieval operation. Okay, and we will delete the data. Only these three operations are permitted in stack. Okay, we will store the data, we will delete the data, and we will read the data. Okay, but what is the condition here means? All these three will happen at only one end. Okay, so if you are considering an array, normally in array, in any place you can store the value. A of 5 equal to 10, A of 7 equal to 20. Like that, using index, you can store in any place in an array. Okay, but in stack, it is not possible to access the rest of the elements. Only the topmost element. Only in that place you can insert value, and delete also. Only the top value you can delete. So if you're considering this array as a stack, so whenever you are inserting an element, you will have a variable called top. If the array is empty, then top value will be -1. So if you wish to insert a value, okay, increase the top. So -1 plus 1 equal to 0. So in the 0th index, that value will be stored. Okay. Suppose if you wish to insert one more element, increment the top 1 equal to the next value. Suppose if you wish to insert one more value, increment the top 2 equal to the other value. Okay. Suppose if you wish to delete only the current top, okay, top is now pointing to 2. Only that element you can remove. You cannot go and remove the 0th index or first index. It is not possible in stack. Okay. What is a stack means? A stack is a linear list in which all additions and deletions are restricted to one end, that is called as a top. Okay, restricted to one end. Okay, addition of elements or deletion of elements, whatever we are doing, it will happen only at the one end. Okay, suppose we are taking a stack of coins. Okay, if you wish to place a coin, means you can place it only on the top. Okay, you cannot insert in the middle. Okay, so logically you can try to insert in the middle, but in the stack data structure it is not allowed. It is restricted. So you can place coin only on the top of the stack of coins. Suppose if you wish to remove a coin, only you can remove from the top of the coin, and you can find what is the value of the top of the coin. Okay, that is reading the stack value. The same way, a stack of books, you can place one book on the top of the stack, and you can remove a book from the stack, and you can read the title of the book on the top of the stack. Okay, you cannot read the titles of the middle of the books. Other than the top of the book, the other books titles you cannot read. Okay, so this is what stack data structure. Okay, so it has its own advantages. Okay, so the stack is used in many places. Okay, in compilers. Okay, that examples we will see after discussing about the stack implementation. Okay, so here itself one example is explained. Okay, if you insert a series of data into the stack and remove it, okay, the removal of data will give the reverse order. So if you wish to perform string reverse operation, simply you read all the characters and push it into the stack, and simply you remove it. You will get the reverse of the string. And the stack data structure is called as a LIFO data structure. It means that last in, first out. So in a stack, whatever the data you are putting last. Okay, if you wish to remove any element from the stack, means only the last element will come as the first. Okay, so just to keep some books one on another. Okay, whatever book you placed last, that book you can remove it as a first. LIFO data structure. Okay, last in, first out. This is the LIFO data structure. Okay. Now, what are the basic operations supported by stack? Okay, there are three operations. There is a push, pop, and stack top. Three operations: push, pop, and stack top. Okay, what is push operation means? The insert value means adding an element into the stack is called as a push, and removing an element from the stack is called as pop. And stack top means it will simply read what is the value in the top. Okay, that is what stack top operation. Okay, so let us discuss the first operation, push operation. Okay, we will see all the implementation in the next class. Today, just the theory part we'll cover. Okay, push operation. Push operation means adding an element at the top of the stack. Okay, if you are seeing the diagram here, in the stack, the top is pointing to the topmost element. Okay, and the push operation, it will carry one data, and the data will be placed on the top of the stack, and the top pointer now it will point to the new element. Okay, so whenever you are adding an element, the top must point to the new element. Okay, you must increment top, and in that location the new element will be placed. Okay, so this is what push operation. Okay, here what we need to check means whether we have sufficient memory for the new data. Okay, suppose if you are using dynamic memory concept and the linked list means if the memory creation error, any memory creation error happens, then it is not possible to add an element. Suppose if you are using array concept, you must ensure that the array size is not yet reached. Okay, array size, the top must be less than or equal to array size. Okay, the top value cannot be more than the size of the array. Okay, in array implementation, we must ensure that the top is less than the array size. Okay, it is important. Okay, and the scenario is called as a overflow. Whenever there is no sufficient room for the new element, it is called as a stack overflow. Okay, the second operation, that is pop operation. So pop operation means removing an element from the stack. Okay, in linked list we inserted data and we deleted data. There we called it as a insert and delete. In stack, the same operation we are going to implement, but here the name is push and pop. That's it. Okay, it is operation names specific to stack. Okay, pop operation removes an element from the stack, and after removal of the element, the top pointer must be decremented and it should point to the previous element, the older element. Okay, so here if you're taking in the picture, so we have a stack and the top is pointing to the topmost element, and the pop operation removes the topmost element and returns to the calling function or to the user and decrements the top. So now top is pointing to the previous element. Okay, so this is pop operation. Here we will have one situation called underflow. Means whenever you are trying to access the call the pop operation on an empty stack. Okay, the stack is empty and still if you are trying to pop an element means this is called as an underflow. Okay, and stack top. Okay, stack top is simply reading top value. Okay, top element's value. Okay, whatever the top element is there, what is the value available in the top element. Okay, so simply reading it is called as a stack top. Okay, stack top pop is the item at the top of the stack and it returns it to the function, okay, calling function or to the user. Okay, this operation is like reading the stack top. Okay, and the stack top can also result in underflow because in empty stack we may call the stack top operation. So since there is no element, it may generate underflow error. Okay, so these are all the three basic operations of a stack. Here some illustrations given. Okay, so in step 1 we are taking green, the stack is empty and we are pushing green, so top is pointing to green. And in step 2 we are pushing blue. Okay, and blue is inserted. Okay, and again in step 3 we are performing pop operation. Okay, the top is pointing to blue, so blue is removed and the stack contains only green. Okay, again we are pushing red. Now green means the red is pushed on green. Okay, again one stack top operation. So stack top operation means it will not modify the top pointer. It will read what is the value in the top. In top, a red value is there, so red is returned. See here, still the stack contains two elements, green and red. Before the operation also green and red, and after the operation also green and red. Okay, top is still pointing to the red. Okay, and again pop operation, red is removed, and again one more pop operation, green is popped. Okay, now stack is empty. Okay, some illustrations. So please understand this concept. Sometimes in exams they will give some list of operations and they will ask you finally what is the value of the stack. Okay, what are the values are there in the stack. Okay, so you must call all the functions and check that means right. Finally, what are the values available in the stack? Okay. Now linked list implementation of the stack. So yes, sorry, stack can be implemented using many data sets. Even you can implement it in array also and the linked list also. So linked list, how to implement it? So as we have discussed about a general linear list implementation using linked list, okay, the same concept here we can apply. So linked list means always we can have two nodes. There is a head node and a data node. Okay, head node and data node we can have. Okay, so conceptually a stack you can write it like this, the A picture A, and a linked list implementation. One head pointer, it is pointing to the first node, the top node, and the top node is pointing to the second top, and second top is pointing to the third top, and so on. And finally, the last node, it is pointing to null. Okay. So header node and data node. So here also you can keep the count value on top pointer in a structure, and the data and the link in a structure in another structure. Two structures we can create: head structure and node structure. Okay, and based on the requirement of the application, you can keep additional values in the stack head structure also. Okay, so count, time of stack creation, and etc. etc. Some additional data also you can store it in the head structure. And these are all the algorithms we are going to discuss. The implementation we are going to discuss creating a stack, pushing stack, popping up stack operation, stack top, empty stack, full stack, stack counter, and destroy stack. Okay. So here in create stack, okay, create stack, if you are comparing the create list algorithm and the create stack algorithm, both will look like similar. First allocate memory, there also we will allocate memory, and setting the count value to 0. Here also setting the count value to 0, and setting the top to null, and here also, just 1 minute. Okay, so if you're comparing the create stack and create list algorithm, create stack and create list algorithm, both will look like same. Okay, here also we need to create the head node first and initialize the count value to 0. Initialize the count value to 0, and then initialize the head pointer to null. Okay, so this is create stack algorithm. Okay, next is push stack. Okay, so here push means this algorithm also, it is the same as the insert beginning of the list algorithm. Okay, in list how we implemented insert beginning. Okay, the same way here we need to implement the stack algorithm, because always in stack we will insert values in the beginning, that is in the top. Okay, the top element will be pointed by the head. So insert beginning, if you understand the insert beginning of the list operation, the same code we will write it here. Okay, that's why I insisted many times that please understand the list operations, the insert operation, delete operation, please thoroughly understand it. Okay, then it's very easy to implement the stack and queue algorithms. See here in push stack, first we need to create a new element, that is p new, allocate the memory, then assign the value for the data. Here data is assigned with red, and a link. Now this p new link, okay, it should point to the node that is pointed by the top. Okay, so blue's address is stored in top. Now blue's address, store it in red, that is p new link equal to stack top. Okay, in stack top, whatever address is available, that address you copy to p new link, and stack top equal to p new. Two pointer operation we need to change. The new node must point to blue, and the top must point to red. Okay, so these changes we need to make. See here, after the changes, top is pointing to red and red is pointing to blue. Okay, now blue is pointing to green. Okay, so three data are stored in the stack now. Okay, and the count must be updated by 1. Okay, before insertion the count value is 2, and after insertion the count value is 3. Okay, and one more important thing is in stack operation there is no display operation. Okay, display operation means displaying all the contents of a stack. It is not possible because you cannot access the other elements. Only top element you can access. If you want to display the entire stack means you need to access each element and display it. That is not permitted. Okay, so display of stack operation is not a correct stack implementation. Okay, now